Hey there, space fans! Today we are going to talk about the big guy in our cosmic neighborhood, the sun. It's the reason we are all here, basking in its warmth and light. Without the sun, there would be no life on Earth, no plants, no animals, not even Instagram. In this essay, we are going to take a deep dive into the heart of our very own star. We will learn about its incredible size and power, how it produces all that energy, and the amazing phenomena that occur on its surface. So buckle up, and get ready for a journey to the center of our solar system. We will also explore how the sun affects our planet, from the weather to the tides. And we will look into the future to see what happens as the sun ages. Get ready for some mind-blowing facts and cosmic wonders. Let's get started. Let's start with some basic facts about our very own star. The sun is really big. I mean really big. It is about 109 times wider than Earth. Imagine a basketball next to a tiny mustard seed. That's the size difference between the sun and our planet. The sun is also incredibly massive. It contains about 99.86% of the total mass of our entire solar system. That means all the planets, moons, asteroids, and comets combined make up just a tiny fraction of the sun's weight. Talk about a heavyweight champion, and even though it looks like a giant ball of fire, the sun is mostly made up of hydrogen and helium gas. These gases are held together by the sun's powerful gravity, which is 28 times stronger than Earth's gravity. That means if you could stand on the surface of the sun, which you can't because it is way too hot, you would weigh 28 times heavier than you do here on Earth. Finally, the sun is located about 93 million miles away from Earth. That sounds really far, and it is, but it is actually the perfect distance for life to thrive on our planet. So, next time you're feeling small and insignificant, just remember that you are a part of this amazing solar system, all thanks to the mighty sun. Now let's peel back the layers of the sun and see what's happening inside. Think of the sun like an onion, but a lot hotter. It has different layers, each with its own unique characteristics. At the very center of the sun is the core, where the real action happens. Temperatures here can reach a scorching 27 million degrees Fahrenheit. That's hotter than a hot pepper eating contest in a volcano. Surrounding the core is the radiative zone, where energy from the core slowly makes its way outwards. This journey can take hundreds of thousands of years. Imagine being stuck in traffic for that long. Next comes the convective zone, where hot plasma rises to the surface, cools down, and then sinks back down. Think of a lava lamp, but on a much grander scale. Finally, we reach the sun's outer layers, which are visible from Earth. The photosphere is what we see as the sun's surface. It's where sunspots occur. Above that is the chromosphere, a thin layer of the sun's atmosphere. And lastly, we have the corona, the outermost layer of the sun's atmosphere. This is where you can see those beautiful streamers and loops during a solar eclipse. It's like the sun's halo. So, how does the sun generate all that energy? The answer lies in the core, where temperatures and pressures are so intense that hydrogen atoms fuse together to form helium. This process is called nuclear fusion. Imagine taking two small marbles and smashing them together so hard that they fuse into a slightly bigger marble. That's kind of what happens during nuclear fusion, but on a much smaller scale and with a lot more energy involved. During nuclear fusion, a tiny amount of mass is converted into an enormous amount of energy, according to Einstein's famous equation, E equals mc squared. This energy is what powers the sun and allows it to shine so brightly. The energy produced in the sun's core then travels outward through the different layers, eventually reaching the surface and radiating out into space as heat and light. This energy is what sustains life on Earth. It warms our planet, drives our weather patterns, and allows plants to photosynthesize. Without the sun's energy, our planet would be a cold, dark, and lifeless place. Section 5. The sun's embrace, warmth, light, and life. We have already touched upon how crucial the sun is for life on Earth, but let's delve a little deeper. The sun's energy, in the form of light and heat, is the driving force behind many processes on our planet. Firstly, the sun's warmth is what makes Earth habitable. It keeps our planet at a comfortable temperature, allowing liquid water to exist, which is essential for all known life forms. Secondly, the sun's light is the primary source of energy for photosynthesis. Plants use sunlight to convert carbon dioxide and water into glucose, a type of sugar that they use for energy. This process releases oxygen into the atmosphere, which is what we breathe. But the sun's influence doesn't stop there. It also plays a major role in our weather patterns. The uneven heating of Earth's surface by the sun drives atmospheric circulation, creating winds, rain, and other weather phenomena. Moreover, the sun's gravitational pull is what keeps Earth in orbit, preventing us from flying off into the vastness of space. So, the next time you feel the warmth of the sun on your skin, or marvel at the beauty of a sunset, remember that you are experiencing the power of our very own star. Section 6. Solar fireworks, flares, spots, and winds. The sun might seem like a calm and steady presence in the sky, but it is actually a very active and dynamic star. It is constantly undergoing various changes and eruptions, collectively known as solar activity. One of the most dramatic examples of solar activity is a solar flare. Imagine a massive explosion on the sun's surface, releasing a burst of energy equivalent to millions of hydrogen bombs. That is a solar flare. Then there are sunspots, which are cooler, darker regions on the sun's surface. They are caused by intense magnetic activity. Think of them as temporary freckles on the sun's face. And let's not forget about the solar wind, a constant stream of charged particles that flows out from the sun in all directions. It is like the sun is constantly exhaling and its breath can reach all the way to Earth. While solar activity might sound scary, it is actually a normal part of the sun's life cycle. However, intense solar flares or coronal mass ejections known as CMEs can disrupt satellites, communication systems, and even power grids on Earth. So, scientists keep a close eye on the sun's activity to predict and mitigate any potential impacts. Section 7. The sun's story, from birth to afterlife. Like all stars, our sun has a life cycle. It was born from a collapsing cloud of gas and dust about 4.6 billion years ago. That means the sun is about halfway through its main sequence lifetime, which is the longest and most stable part of a star's life. But don't worry, the sun won't be going anywhere for a very long time. It has billions of years worth of fuel left in its core. However, as the sun ages, it will gradually change. In about 5 billion years, the sun will run out of hydrogen in its core and start burning helium instead. This will cause the sun to expand and cool, transforming it into a red giant. As a red giant, the sun will become so large that it will engulf Mercury, Venus, and possibly even Earth. Talk about a bad sunburn. But don't fret, this won't happen for billions of years, so you have plenty of time to update your sunscreen. Eventually, the sun will shed its outer layers, leaving behind a small, dense core called a white dwarf. This white dwarf will slowly cool down over trillions of years, eventually fading away into a black dwarf. Section 8. Fun in the sun, curious facts about our star. Now let's lighten things up with some fun facts about our amazing sun. Did you know that light from the sun takes about 8 minutes to reach Earth? That means if the sun were to suddenly disappear, don't worry, it won't. We wouldn't know for 8 whole minutes. Here is another one. The sun's surface temperature is a scorching 10,000 degrees Fahrenheit, but its corona, the outermost layer, can reach millions of degrees. That is like having a cold drink on a hot summer day, except the drink is millions of degrees hotter than the surrounding air. And get this, the sun rotates, but not all parts rotate at the same speed. The equator of the sun takes about 25 days to complete one rotation, while the poles take about 36 days. It is like a giant cosmic merry-go-round where the horses on the outside are moving faster than the ones in the middle. Finally, did you know that the sun is constantly losing mass due to nuclear fusion and the solar wind? It is like a giant cosmic weight loss program, but don't worry, the sun has a lot of mass to lose. Section 9. A starry farewell, the sun's enduring legacy. As we come to the end of our journey to the sun, it is important to appreciate the profound impact this celestial object has on our lives. The sun is not just a ball of gas in the sky, it is the reason we are here. It provides the energy that sustains all life on Earth, drives our weather patterns, and even influences our moods. From its impressive size and power to the intricate processes happening within its core, the sun is a constant source of wonder and fascination. And while its life cycle may seem finite, its legacy will continue to endure long after it has faded away. So, the next time you look up at the sun, take a moment to appreciate its warmth, its light, and the vital role it plays in our lives. And remember, there is still so much more to learn about this amazing star. Keep exploring, keep asking questions, and never stop being curious about the universe around us.